Is voice fully clear? I'll start. Today I increase size, I enlarge so that the other things are not visible. Writing area becomes lesser, but at least it will be more clear. Voice clear? Again, as usual, no comment. Clear? Okay, I'll start. See, first, as I told, it is numerical. Today is full numericals only. Now, what I will do is, first summary brief I will write here. See, now no more discussions. See, now there will not be much discussion, long, short, etc. Everything is told. So, therefore, those things will not be told now. There's a limit for explaining everything. See, first of all, see, Euler's buckling load. Euler's buckling load. Buckling load. This is, remember, valid only for long columns. Long columns. You can write here, which fails by buckling alone. You should write. How many times I have to write? Which fails by buckling alone. That is PB equal to pi square EI. I means I minimum. Now I will not tell. I told 1,000 times. It is not I minimum. In RCC and steel, it is applicable I. But in strength of materials, since you consider L effective same with respect to both the axes, it is I minimum. Okay, sufficient. It's a formula. See, this is the original formula. Remember, this is the original, or you can tell derived formula. Derived formula. But practical, but more better, or you can tell not practical. Okay, but practical or more, what you can tell, either practical or more sensible. Sensible is buckling load PB equal to pi square E. All you have to do is what? I minimum replaced by what? AR square. So A will come there, R square will come denominator, L effective by R square, L effective by R whole square by lambda square. This is more sensible and concept based here. This is, both are identical, remember, both are same formula. Okay. This is what? Euler's buckling load. Okay, then further, after Euler's buckling load, terms I will put it later. Rankine's failure load. See, Euler's is buckling load. Rankine's is failure load. In the bracket, valid for any type of column. Any type of column. Someone will ask, what is the type? You write, that is either long or short or intermediate. The symbol is PF equal to what? Sigma CR into A divided by 1 plus alpha into lambda square. Okay. These are the two equations you write. Now, 1 minute. I will give term by term explanation to understand. See, pi, common for both. Pi, I don't have to explain. E, you should write, no time for me. Modulus of elasticity of material. Someone will tell, sir, why not written? Write it if you want. Okay, then I minimum is, I am dictating, least moment of inertia of cross section. You should write, those who want to understand, you should write after the class. Once again go to recording. Then write. You cannot, this all written so many times. So repeatedly, why should I write? People who are serious, they will write. Okay, then I minimum over. Further, A is cross-sectional area. Okay, over. Then, next you require what? Pi square EI. L effective later. Pi square EA over. Now, L effective lambda are connected. See, I will put lambda is slenderness ratio. Slenderness ratio. Lambda equal to L effective by R minimum. Okay, now we are considering L effective and lambda both R minimum. Further right, L effective is effective length of the column, which is to be obtained based on actual length L. I told serious people will write actual length L and end conditions. End conditions. Okay. Then R minimum is least radius of gyration of cross section, and R minimum equal to square root of I minimum by A. Everything is over. Sufficient for me, space. Okay, this is also over. Now, next, some discussion. Remember, one important note. One thing is still pending. What? See, alpha is pending. If you are applying Rankines, alpha is Rankines, you write Rankines material constant. Remember, material constant. Some people, they spoil it. They give alpha for both end fixed, alpha for both end hinged. It is, I feel, that way giving, of course, they will correct L, instead of L effective, they will take L then. But it is utter nonsense. When you derive, alpha is what? Pi square L, FCR, sigma CR by pi square E. That is material constant. Why should they introduce end conditions for alpha? It is completely nonsense. If they come in front of me, I will prove them. You write alpha. Why you are mixing end conditions? It is a pure material constant. Those who come to my class follow my procedure. Okay. Now, alpha. And alpha equal to sigma CR by pi square E. It is pure material constant. No unit for that one. Okay. Now, everything is explained. Lastly, remember, you should write Euler's formula is applicable, you should write only if slenderness lambda is either equal or more than, how to remember, same alpha, take reciprocal, but root comes there. Root of pi square E by sigma CR. We even discussed for steel. Tell me how much you got yesterday? 77 point. How much came? We got it for steel. Any material you can find. How much you got? Some 77 point something came yesterday. If you remember, for my steel. 77 point, I don't remember now. Numbers I don't remember always. I'm very weak in remembering numbers all. Okay, that is not a problem. Then, this is also over. And remember, if Euler's formula can be applied if lambda is either equal or more than pi square E by sigma CR. But actually remember, if lambda is more, Euler's formula will not give correct answer. Reduction factor is there. But if it is highly more, if this number is 70, 80, this is 300, 400, okay, then correct. Then column will fail by buckling. It is really long. If it is 77, if it is 78, okay, Euler's formula can be applied, but it will give more than the buckling failure load, so not dependable. That's why Rankine's formula, reduction factor is there. And now, one more statement. If you see Rankine's formula, see, PF, you can write PF equal to sigma CR into A. You can write this way. This is nothing but crushing load. Crushing load. Multiplied by 1 by 1 plus alpha lambda square. Tell me. Now, if the column is very, very short, column will fail by crushing. Yes. Then you can tell crushing load, failure load equal to crushing load. Tell me. Then how much this will come? Almost. If the column is very, very short, you should, these all you are right after the class. If the column is very, very short, tell me how much it will come, this value. Very near to what? It will come to very near to equal to, no. If the column is short, this number will come, this all right after the class. You write everything after the class, not simply see the board. I am rubbing everything now. Everything I am rubbing now. If the column is very, very short, then this value will come almost equal to how much? Tell me. I told yesterday. There is no reduction. Almost equal to. See, then this will be very, very, very small. Then this value 1 by 1 plus alpha lambda square, your lambda will be very small. This will almost come equal to 1. If the, right here. So you can write here that 1 by 1 plus alpha lambda square is called, you can call it as reduction factor for which load? Tell me. Crushing load or buckling load? Reduction factor for crushing load or buckling load? Tell me. You can call 1 by 1 plus alpha. See, in steel structures it is there. You can call it as what? Reduction factor for crushing load. Good. For crushing load. Crushing load. And make a note. It is a mathematical sense. Suppose you write here. You have 100 rupees. Rupee because India. 100 rupees. I want reduction factor. No, not 100 rupees. Sorry. Tax. Tell me tax. See. When you have earning, okay, you are earning, money matter is better. I will not tell once again, earning. Now, see, suppose earning is 10,000 rupees. You can imagine per day also, no problem. 10,000 rupees. Tell me. If there is no tax, tell me how much, no deductions in the, see, there is no tax, nothing, no reduction. Full money will come to you. Tell what money you will get. Tell the answer. If the earning is 10,000 rupees, if there is no tax or no reduction, how much money you will get? This is crushing load. How much money you will get? How much money you will get? See, some earning is there. No discounting. Full. See, or TDS you can call. TDS. Full 10,000. Why? It is 10,000 into 1. 1 means no reduction. Clear? 1 means no reduction. Clear or not? Not 0. When there is no reduction, reduction factor is 1. It is not 0. Don't think 0. Clear? No reduction into 1. You are not telling. Clear or not? Into 1. 1 clear means okay for me. I will be convinced. See, this much difficulty for writing. Clear or not clear? Into 1. No one should clear. Okay, now, suppose imagine there is a tax of 10%. Tell me, how much you get? 10,000 into not 0.1. Tell how much you will get? 10,000 into how much you will get? Suppose there's a tax of 10%. Then money you will get is 10,000 into how much? Not 0.9, not 0.1. How much you will get? 10,000 into how much? 10,000 into number. 10% discount or 10% tax or 10 TDS. 0.9. That 0.9 is called reduction factor. Reduction factor. Reduction factor more means reduction is lesser. Reduction, now, by chance, imagine this is for 10%. Suppose 30% tax, then you will get 10,000 into 0.7. That is 7,000. So remember, as the reduction increases, what will happen? As the reduction increases, reduction factor will what? As reduction increases, reduction factor will. This is mathematical. As reduction increases, reduction factor will. Tell me. Reduction factor will reduce. Reduction factor gives you what? Reduction factor will not give you how much reduction. It will tell you how much still remains. Clear? Reduction factor is after reducing how much still remains. 10% tax. Reduction factor is 90%. If 10% cut, you get back 90%. If tax is 20%, reduction factor is 0.8. If tax is 60%, oh, terrible. Maybe emergency. Reduction factor is what? 0.4. If 60% tax is there, what? That is, you will get only 40%. Yes. Therefore, remember, reduction factor is what? Reduction factor is 1 minus that number by which it will reduce. Clear now? Now, therefore, tell me, you want salary point of view, high reduction factor or low reduction factor? Tell me. Suppose salary point of view, you want high reduction factor or low reduction factor? High reduction factor or low reduction factor? Tell me. Reduction factor is how much still remains. Salary point of view, what do you want? Or any income point of view, you want high reduction factor or low reduction factor? High factor. Reduction factor high means after reducing, still more is left out. Reduction factor low means after reducing, little is left out. So, for a column, if reduction factor is 1, means to crushing load. If reduction factor is 1 to crushing load means what? You need not reduce the crushing load to get the actual failure load. Means column is extremely what? If reduction factor is 1 means no reduction. Why? Full you will get. If reduction factor is 1, column is extremely what? Short or long? Column is extremely short or long. This is technical. Extremely short or long. Okay, strong, correct. I want short or long. Extremely short. So, as the column becomes long and longer, that is, as lambda increases, strength will decrease. When strength will decrease, reduction will increase. See, as the strength decreases, reduction will what? Reduction will increase. But reduction increases means reduction factor will become lesser and lesser. So high reduction factor means column is going to be what side? Long or shorter side? Reduction factor increases means column is becoming more and more slender or less slender. As reduction factor decreases means column is becoming less slender or more slender. Reduction factor decreases means reduction factor decreases. It becomes long. Okay, sufficient. Those who are serious, they will write all these and thoroughly study. Okay, over. Now, lastly, before I start the numericals, I will tell one thing, because I wrote this as strength of materials. So practical aspect of this one application, like the formulas used by IS code or IS 456 or steel, that 800, that comes in the steel. There you get stress reduction factor. In RCC, IS code will tell L effective by side. If it exceeds 12, take long column, consider extra bending moment for design. That all we can't decide in strength of materials. But I already told you the practical meaning of everything. So, since I wrote this is strength of materials, Even students can use it. For them, one extra information. See, extra information. PB as per Euler or PF as per Rankine. What is that one? If the column is very long, column fails by buckling. If the column is very short, column fails by crushing. If it is via media, it fails by mix-up. So, if you apply Euler's formula, you get buckling load. If you apply Rankine's formula, name only is there. Rankine's failure load or critical load. They are, both of them are permissible load or failure load. This is when column will buckle. This is when column will fail. Both of them are separately by concept, by respective theory, they are permissible load or failure load. I will not tell once again. They are by respective approaches. If you call Euler's formula PB, they are actual permitted load or failure load. What? Permissible. You allow a column to, you construct a column where you apply a load at which the column will buckle. How possible? Failure, permissible load. How idea came? In RCC all you get factored load, ultimate load, same way. These are failure load. So you permit this load in actual construction. Suppose there is a column which is failed to buckle at 100 kilonewton. You will tell, okay, apply 100 kilonewton. Or a column by Rankine's formula tells failure takes place at 500 kilonewton. So how much shall I apply? Apply 500. How idea came? How the idea came? I don't know. By mistake actually possible. It is not possible. These are failure loads. Are they permissible load? They are failure load. So practically if you find PB or PF, a column, when it will buckle or when it will fail by respective theory, can you actually apply that much load, working load? Can you actually apply that much load? Tell me. Can you actually apply that much load? Can you apply that load? Okay, apply the load. Can you actually apply that much load? Yes or no? Answer. Column fails at 200 kilonewton. No, you cannot apply that one. Therefore, there is a term called safe load, either called safe load or called maximum permissible load or called maximum allowed load, or in IS code point of view, it is called what? Tell, what is the name? It is also called as what? Properly. Also called as working load or one more name, service load. Correct? You can call either safe load or maximum permissible load in the actual field conditions, or maximum load allowed for safety, or a safe load, working load or service load. That will be equal to either PB if you apply Euler's formula or PF if you apply Rankine's formula. Shall I divide or multiply? Tell me, a term required. Shall I divide or multiply? Shall I divide or multiply? Further, I will not explain why. This you know it. Shall I divide or multiply? By a number. A number more than one. Divided by what? A term called factor of safety. That is a safety margin. Remember, or just example. Suppose imagine a column fails at 200 kilonewton. Factor of safety required is 2. Tell me what is the maximum load practically allowed for that column? 200 kilonewton, column fails. But people want safety. You cannot load up to failure load. Tell me, what is the maximum load you can apply? 100 kilonewton. 100 kilonewton. Okay. Now, one more concept. Remember, I will remove this one all. One more concept. A column is actually loaded by 100 kilonewton. 100 kilonewton. Oh, okay, not 100, leave it. 500 kilonewton. Actual load. Now, factor of safety required is 2. Therefore, you should consider the column therefore, column should fail means what? Either buckling or Rankine's formula. Column should fail at what load? 500 divided by 2. How much answer? 500 divided by 2. Not visible. Oh, sorry. Ayo, I forgot. Okay. I put a line there. What happened is I forgot. Okay. I'll remove all this because why? Everything is told so far. Those who are serious, they will write and solve the problem. Those who are not serious, why should I bother about them? Okay. Now, this all I told you. Now, last one concept, just to understand. I just now told, if a column is found to fail at 200 kilonewton, and if you want a safety margin of 2, factor of safety of 2, then practically or in the actual field conditions, you should apply a load maximum of 200 by 200. Why? 200 will fail. But safety, you apply only 100 kilonewton. Now, another column. A column is loaded by 500 kilonewton. It is the actual load applied. It is subjected to a load of 500 kilonewton. Next. Factor of safety of 2 required. Therefore, column should fail. How fail? Long column means buckling. Short means what? Or anyway, fail your load. 1 minute now. Is now okay? Or have I gone above the line? Okay. I think I should come little down. Okay. Therefore, column should fail at what load? 500 divided by 2. How much answer? 500 divided by 2. How much? 500 divided by 2. Last answer. That's all. I start the problems now. Not much problems here. 500 by 2 is 1000. Ayyo. 500 by 2 1000. ಇದ್ಯಾವ ಲೆಕ್ಕಾಚಾರ? 500. 2 2 4 1 ಉಳಿತು 2 5 10 2 2 4 ಏನಾಯ್ತು? 2 2 4 ತಮಾಷೆ ಮಾಡಿದೆ ಅಷ್ಟೇ. ಎಷ್ಟು ಆನ್ಸರ್? Actually, someone will tell, if the people know me, they will enjoy. If a newcomer is there, or if there's a competitor is there for me, when I wrote this way, he will be so happy. Why? He'll be so happy. Oh, this person cares and talks too much. See what blunder he made. They'll be very happy. But those who know me, they know why I am doing this one. Tell me why. It's a joke actually. It is not 500 divided 2. It is what? 500 multiplied by what? Not divided by 2. Multiplied by 2 equal to 1000 kilonewton. Because column is already loaded by 500 kilonewton. Then you do not want the column to fail at that load. You should have a strength so that it will fail at 1000 kilonewton. Clear? Tell me. You should correctly observe how to whether to multiply or divide by factor of safety. If you are finding safe load from failure load, divide by factor of safety. Whereas if you know the load applied, you should see that column will fail at a higher load. Fully clear? Fully clear or not? First, concept fully clear? No sir. Hale no nadu. Is the concept fully clear? This I am telling for general public. Those who are regular viewers here or those who are regularly attending, you know this one. Clear? Okay. Or I will give lastly money matter example, so that no confusion. First of all, I should not tell. See, suppose monthly income is say 50,000. Save the money. He wants to save the money. He do not want to spend everything. He decided, I want factor of safety of 2. Tell me, how much money he can spend? He can spend means what? In the case of column, how much load you can apply? Tell me. 550,000 rupees monthly income. He want to see future expenses and safer side in life. He want to save money. He decided, I will spend with the factor of safety of 2. Tell me, what is the maximum money he should spend? How much? Maximum he can spend is how much? 50,000. How much answer? 50,000 is the monthly income. Divide by 2. He will spend only 25,000. This is clear. Okay, now, second example. This is what? See, 50,000 is the ultimate. Permissible is 25,000. This money matter, everybody will be clear. Or, second case, somebody is planning for a tour. Planning for a tour. He estimated the cost, maybe 10,000 rupees. Some tour. 10,000 rupees, rough estimate. Train on the 500, their room rent is around something, etc. etc. He roughly estimated 10,000. But he is a very safe person. He told, no, I do not want to take chances. Tomorrow suddenly cost can increase. So I want factor of safety of 2. Tell me, how much money he should take with him? How much money he should take with him? Before going to the tour, no card. Card is not allowed. Imagine this is 30, 40 years earlier when debit card was not there. Someone will tell, sir, debit card, credit card is not there. This was the time, 40, 50 years earlier. If he estimates the expense to be 10,000 and he wants factor of safety of 2, how much money he should take with him for safer side? Answer, Istotbeka. How much money he should take? Last, I am closing now. 20,000. Why? 10,000 into 2 now. Not 5,000. If you divide by 2, it is nonsense. When people will understand money matter very easily, correct? They will understand money matter very easily. Sir, clear, sir. Sir, Kannadadalli. Sir, ashtu gottagalva. Enu pedra ನಾವು ಹಿಂದಿಲಿ. Sir, क्या मैं बेवकूफ हूँ? ये सब मुझे पता है. English what you can tell. These all known, sir. I am not a fool. But I will tell you sometimes tell foolishly in structural language. Sir, that is structure, sir. What to do? This is day-to-day life. Okay, done. So therefore remember, if a column is found to fail at a load, you apply lesser load. Divide by factor of safety. Or if you want to apply a particular load, if you know how much is the load, you see that column will fail at a higher load. If the column fails at, say for example, 100 tons, you apply only 50 tons. But if you want to apply 100 tons, let the column have ultimate strength of 200 tons. Is the concept fully clear? Write everything. Those who are serious, write everything, including money matter. It will help you one fine day. Clear? All clear means I will go to examples now. Full board I rubbed. After the class you can do one thing. What all I wrote, you make a fair copy and write it. Okay, now I will start numerical example. See, I am putting a line here because this much is not visible. Today I decided no disturbance of the board. Board is so clear today. See, today board is so clear that sides all you cannot see. Okay, now start. Question number 1. Question number 1. Right. a steel column of actual length means always actual length, of length 8 meter, quite high length, is of I section 200 millimeter by 500 millimeter. Actually, I will tell this is very nearly equal to ISMB 500. But don't worry. Then flanges are 16 mm thick, and web thickness is 12 mm. This is a cross section. Now, crushing stress for the material. See, I told yesterday 300. No, this time they are telling 325. You can tell MPA. No, yesterday you told 330. No, today I am changing. This steel is found to be slightly weaker. I am giving 325, accept it. Over. And modulus of elasticity, remember, is usually taken 200 GPa, but actually it is little more. Today I am giving 205 GPa. You should not argue. Question given means no argument. Over. Then, next sentence. The column is fixed at one end and hinged at the other end. One question today I am solving systematically. Next time onwards, repetition, I will give instructions, you should do it. Okay. Right. That also given. Next step further. Find safe load on the column, safe axial load on the column. Understood? Safe axial load on the column with a factor of safety of 2.5. Somebody wants a factor of safety of 2.5, means if the column fails at 250, he will tell, I am applying only 100. If my monthly salary is 25,000, I will spend only 10,000. Remaining money I want for future. Okay, over. Now, apply based on, find the safe load based on both Euler's and Rankine's formula. Apply both. See, he told you apply both independently. Lastly, comment. Comment I will give. Okay, start. Solution. Irrespective of whether column is fixed or hinged or this one or that one, L effective, Euler, Rankine, whatever you apply, tell me. First, you write cross section. How is the column? See, the column is an I section. See, this way. Actually, remember, this is the actually column, rolled sections. See, this is the column. Okay. This is the column. This is the load applied. This is how the column is. This is a cross section. Now, length is given how much? 6 length. Length is length I not given. Oh, I given length. It's 8 meter. Okay. Now, this is the column. Now, if it is a steel column, you can see curvature here. That is ISMB, ISLB, etc. ISHB. But then the area and moment of inertia will slightly change compared to if you take rectangle. Or do one thing. Nowadays in steel, they are going more and more for fabricated I section, where they are welding the flanges with the web. Then correct. Anyway, and one more thing. If it is ISMB number, you don't have to find area, you don't have to find R minimum, moment of inertia, nothing required. Tell why. If it is a standard steel section, you don't have to find anything. Tell why. Reason. If it is a standard I section, rolled I section, you do not have to find any property practically. Tell why. Directly start the question. Reason. If it is standard I section, given in actually not steel table, it is given in IS handbook. It is called IS handbook. Steel table is a what? Private copy. They took permission from IS code, IS department and published it. They took permission and published. Technically called IS handbook. Number I don't know. Okay, start. Now, but here, what? Here, handbook is not there. So, first write cross section. Load is applied like this. You cut here. You can write the cross section either like this or like this. No problem. Usually in India, when you write I section, you usually write I section like this. See, this is the usual way people write I section in India. And in the handbook, see, both are equal flanges. See, I won't test for moment of inertia now. If it is unsymmetrical section, you should know how to locate center of gravity, how to find moment of inertia. That all I won't discuss here. This is not academic class, but useful for academic. And one more thing, usually examinations, if it is academics, if any student is watching, they don't give unsymmetrical for column. They give symmetrical, so you can use it. Okay, now I will put the dimensions here. This dimension is 200, they told. Then 500 is the overall depth. Overall depth 500. They told flanges are 16 thick. All dimensions are in millimeter. Remember, web thickness is, they told 12 mm. Now, consider three parts here. You can do whatever you want. Okay, now, first you write, see, first I want what is, I write here, what is cross-sectional area. A, I want area in millimeter square. One number I want. Okay, then if you see Euler's or Rankine's formula, then what do you require? Always you require least moment of inertia of cross section, that is I minimum required. I minimum I want in 10 to the power 6 millimeter power 4 I want. Okay, that is here. First you find area. Enjoy and get area. 1 minute. Let me see the up to where visible. Oh, fully visible. I can shift the board slightly upward. Okay, today I won't change. After you find the area, get in millimeter square, then you find moment of inertia about the principal axis. About the principal axis. So what you do is mark the axis XX and YY. Where principal. Okay. Red color I will use. When I want red, I won't get red. It's a curse. Okay, got it. Luckily. Slightly out of shape. Don't bother tell me he do not know right how to write sections all in the okay. That's a secondary. See now. CG here, CG here, CG here. This is the XX axis. This is the YY axis. Actually, if you know concept, tell me for rolled section, undoubtedly you know those who came to my steel class, I told thousands of times for you. Tell me, which is the weaker one? Which is the weaker axis here? Or which axis has got lesser moment of inertia? XX or YY? I have told it thousands of times in steel class. YY. That is in steel class. This is strength of materials class. For somebody studying third semester, if he is going through my class, he will tell what he is telling, I don't know. So no problem. You happily find I about what? Happily find I about XX axis, then I about YY axis. You find these two, calculate. See, sorry, there is right, that is this answer in 10 to the power 6 millimeter power 4. This also in 10 to the power 6 millimeter power 4. Okay. equal to. This I will not tell. Because if you remember, in the YouTube only, long back in bending stress chapter, 1I section, I thoroughly explained moment of inertia for general public, those who are my regular batch students. For them, moment of inertia already over long back, so systematically over. They are in a position to, they even know the real meaning of moment of inertia, not blindly moment of inertia. Those who are attended my class earlier, this course, BSK course. BSK means basic structural knowledge. Today is class number 198. See, 198. We started from engineering mechanics. At that time, I told you not just how to find moment of inertia. If I remember, I told the real meaning of moment of inertia. Yes or no? 99% people does not know it. Very sorry to tell. I told the real meaning of moment of inertia. Are you agreeing or not? Those who came to my earlier classes. Are you agreeing? The real concept of moment of inertia, not simply BDQ by 12, this way, IG plus AH square, not that way. So, for them there is no problem. And if any new entry is there now, do one thing. Sir, you will tell, sir, I have not come to that class. No problem. Go back to playlist. There's a chapter called bending stress there. In the bending stress, unsymmetrical, symmetrical, both I explained. Go back, my class only. Go back, my class only. Bending stress chapter, if you are not interested fully, see there where I told moment of inertia. Then study and come back. And one more thing. When you are in the strength of materials column chapter, after finishing bending stress, deflection, all this one, now I cannot explain to you how to find I unless there is something special. Okay. Find IXX, IY area. I'll take 2 minutes break. Why? Non-stop I talked. 2 minutes break I will take. 2-3 minutes break. Agreed? Tell me both the values. Others, study and understand. Go back to my old class. It is there in the playlist. Okay, start. Jump. Because I talk too much actually. 2-3 minutes I will take break. One question I will solve systematically today. Explaining every term. Next time onwards, this much I will not tell. Next time is what? Just one more class. Tomorrow. Tomorrow this chapter is going to be closed. Tomorrow I will solve some logical questions. Not this type. What length is possible for the column, or how to find the size of a column. Those things I will tell tomorrow. Okay. 2-3 minutes break I will take. Okay, some answer came. I start. Why waste time? I'll instead of taking break, I'll finish the question, then take the rest. Okay, I'll give the answer now. If it's tallying, well and good. Not tallying, you try to get later. Again, same problem. Yep. Okay. Area equal to 200 into 500. What is the depth of web? Depth of web is 500 minus 32 is 468. Okay. This is my calculation, not required. 200 into 500 minus 1. This is thickness is 12. 188 into 468. Area is 12016. I about x-axis is divided by 10 to the power 6. 477.45. Correct answer? 477.45 is correct. Okay, that is IXX. IYY is still you are not given the answer. Still you are not given the answer. 21.40 10 to the power 6. Anybody got the answer? That is the property of the cross section. It came 21 point something. Correct answer? See, why nobody gave IYY? Why so far nobody gave IYY? Because IXX is traditional calculation. IYY usually people don't do. That's why I think. See, usually people don't go for IYY. Is IYY correct? Tell me. I do not want a wrong value. Because when I continue now, I do not want a comment section. Actually, nobody puts any comment in my class. I do not want that IYY is wrong, sir. I will tell if wrong, come live and tell the correct answer. See, sometime I should be arrogant type only. If wrong, come to attend the class and tell the correct answer. Don't comment wrong later. You tell whether principle wrong, then comment. Don't comment on numericals. You want me to check IYY? Why? Okay. Correct. 21.40 10 to the power 6. I once again got it. I once again got 21.40 10 to the power 6. Okay, correct, correct. I checked second time. I checked second time. Correct it is. Okay, okay. Now, continue. Now, okay, this much over. Come back to our methods. Either buckling load or failure load. Okay, 1 minute. Now, you go to what? Concentrate on what? Buckling load by Euler or failure load by Rankine. Okay. We require area. Already over. 12016 mm square. See, we want not all the moment of inertia. We want least moment of inertia. See here. One of them is 477, other is 21.4. You can write, therefore, IYY is least. Therefore, least value is IYY. Write it here. How much? 21.40 10 to the power 6. Okay, now, with this much data, and remember, I already told what? Now I'll do one thing now. This I will remove now. I will remove this one now. Not required. Cross section is not required. I will come back to what? Back to problem. Come back to problem. Okay, start. Now, first consider Euler's buckling load. First consider Euler's buckling load. Complete the question. Buckling load. Okay, see. If you consider Euler's buckling load, the formula is Euler's buckling load PB equal to pi square EI minimum by L effective square. Therefore, along with the area and I, you require L effective, that is effective length. In the question given, one end is pinned, other end is fixed. Length of column L is told as 8 meter. Tell me, for one end fixed, elastic curve will be like this. Okay. For one end fixed and other hinged. Tell me L effective. Answer. L, what you have to tell me? L effective equal to, all list given for you earlier. One fix, one hinge. L effective equal to L by root 2. Okay. L by root 2. Or equal to 8 divided by root 2. You tell me the answer in meter. Okay, I will calculate. Because why? You take hours together. 8 divided by root 2. 5.65685 meter. 5.65685 meter. But remember, we are going to solve the problem. Make a note here. We are going to solve, when you substitute, etc., we are using newtons and millimeter. Therefore, your L effective equal to 5656.85 millimeter. Okay, start. Now, data is sufficient if you are applying original Euler's formula. See, if you are applying the original Euler's formula, data is sufficient. Substitute then. Substituting, you get PB equal to pi square. I forgot right here. Make a note somewhere. E equal to, told in the class question, modulus of velocity 205 GPa are equal to 205 10 to the power 3 MPa. MPa means Newton per mm square. You know it. Therefore, if you substitute now with these values, your Euler's buckling load will come pi square into 205 10 to the power 3 into I minimum is 21.40 10 to the power 6 divided by L effective millimeter 5656.85 whole square. See, Newton per mm square, mm power 4, mm square. Answer will come in Newton. So tell me in 10 to the power 3 Newton. Answer. This will give Euler's buckling load for the column. Answer. This time tell correctly. I will depend on you. Don't give wrong answer. 1353.06. Okay, done. If wrong, I am not responsible. 13. See my memory power. See the biotic power. Gone. I saw there when I came here. 13 I remember. 13 is an unlucky number in cricket. I remember it. 1353 point. See, I forgot decimal. You can make out how weak I am in by hearting. 0.06. Okay. 0.6. 10 to the power. That is, you can tell 1353.06 kilonewton. This is the Euler's buckling load if you use the original formula. See, over. Now, just make a note. The original formula, you write there, pi square EI by L effective square, which is the derived expression. It is no doubt correct, not that way. But practically, slenderness ratio should come. It is actually there. You can't see it. You cannot see it. So, the more practically or sensible approach is buckling load equal to pi square EA by lambda square. You write that way, pi square EI by lambda square. Therefore, now you require lambda. Lambda is slenderness ratio equal to what? Equal to root. L effective by R minimum. So, therefore, when you put property here, you write one more thing. Therefore, R minimum, least radius of gyration of the cross section. equal to square root of I minimum by A. I minimum is here, area is here. You have got a calculator with you. Substitute and tell me the answer. R minimum. Tell the answer in millimeter. What is this? I remove. What is the R minimum? Oh, 56.85. Okay. R minimum. What is the answer? It comes in millimeter. If it is ISMB 500, I think R minimum is around 40 odd millimeter. Around 40, I remember. Yeah, I told you, see, I take steel structures also. If it is ISHB series, R minimum is around 50, 60 is there. Therefore, remember, in steel class I told, ISHB is superior to ISMB for column. But ISMB is much, much superior to ISHB if it is beam. Remember it? Remember or not? In the steel class I told you. Do you remember it? ISMB is no. For column, HB is more superior. Yes. Anyway, forget it. It is equal to, how much you told? 42.201. See, I told around 40. 40 I told. How I remember number? If I see steel table, it will not be same number because why? Dimensions are not exactly as per steel property. Okay, over. Therefore, slenderness ratio lambda equal to L effective, just now I told 56.85 divided by 42.201. Answer. Remember, no unit. This is the slenderness ratio for this column. Answer. Give me third decimal. Slenderness ratio. I want third decimal. One more number more. To be more accurate. One more number more. See, always when you give more number. Then I can select. Lesser number means I can select. If you give lesser number, higher I can't select. $134.045. Correct? Ayo, 1134 means gone case for the column. 134.045. 134.045. See, no unit. Suppose I calculated. If I not calculated, someone typed there. I don't know who typed there. 1340.45. I would have expressed shock there only because a column of 8 meter height with one end fixed one hinge, effective length is around 5.5 meter. I know slenderness ratio will go above 120. I know that much. Above 120 or in the 130 it will come. When you put 1300, I know wrong. Suppose I go to a meal in an ordinary restaurant. I know cost of meals is 110, 120 rupees. Suppose it tells 1300 rupees. I know it is wrong. Okay, over. Now, substituting Euler's buckling load, same answer has to come by using the more sensible formula is pi square into 205 10 to the power 3 into I minimum into area you require. 12016 divided by lambda square is 134.045 square. Tell this answer also in 10 to the power 3 Newton. Tell this answer in 10 to the power 3 Newton. Tell this answer in 10 to the power 3 Newton. Why you tell? You can type the same answer because it is my class. It is my class. No need of checking. It is not a new approach. Same formula, modified approach. What is the answer? Okay, I know a typing mistake. But it should be a typing mistake. Same value, that is 1353.06 10 to the power 3 Newton, or you can tell 1353.06 kilonewton. Or therefore, I will tell the answer now. Red color. Therefore, see, for this column, Euler's buckling load, that is PB, that is the load at which this column will buckle means it will fail by buckling. Remember, you write Euler's buckling load means at what load column will fail by buckling according to Euler's theory is 1353.06 kilonewton is the buckling load. Okay, now tell me answer. Factor of safety required is how much I told? 2.5 as per question. Therefore, tell what is the safe load. Safe load, you write there. Safe load means what? How much load practically is permitted. Or if it is your building, if someone tells that column will buckle at 1353 kilonewton, then how much load you will allow equal to 1353.06, that is whatever buckling load, divided by factor of safety of 2.5, or you can tell this column can be applied, subjected to a load of how much? Around 400, 400. It answer 541.224. Okay, 541.224 kilonewton is the safe load. Okay, remember. Now tell me, Rankine's permissible load based on Rankine will come more or lesser? Answer now only. I am taking a chance. Tell me, permissible load based on Rankine's formula will come more or lesser? Common sense answer. Now only I am committing. This is the load allowed if you tell Euler's formula. No, it will not be more. How it is possible? Rankine will consider buckling effect and also axial load effect. So Rankine will tell buckling will cause bending moment, axial load will create axial stress, therefore that much load you cannot apply. You apply lesser load. Clear? Rankine's load is always less than Euler's load. Clear or not? Rankine's load is always less than Euler's load. Those who told more, clear now? Because Rankine will consider extra effect. He will here Euler considered only buckling. Rankine will consider not only buckling effect, but also direct compression. So column will be more severely stressed. So Rankine told, do not go for Euler theory, use my formula. But he will tell, if the column is very, very long, then I will tell almost same as Euler. You got these all we know yesterday, yes or no? If the column is very, very long, then Rankine will smile and tell. Rankine will smile. He will tell, yes, same as Euler. I am with Euler. The moment column becomes intermediate or shorter, Rankine will tell, don't depend on that person, danger man. He will think of only buckling. He will not consider direct compression. You listen to me. I will give correct value for any column. Clear? Okay, start. Now come to Rankine's formula. Rankine's formula. Rankine's failure load, PF, right here. Rankine's failure load, PF equal to danger. See, red color is danger. Sigma CR into A by 1 plus alpha into lambda square. 1 minute now. See, sigma CR is crushing stress, which is given in the question as 325 MPa. Now onwards, if I write MPa, you know it is Newton per mm square. Then area already known. So if you are doing Rankine's formula alone, any student, for exam point of view, area you have to find, I you have to find, R you have to find, lambda you have to find. Okay, over. Now area over. No. Alpha is Rankine's material constant. See, in one GATE exam they told Rankine's material constant for both and pinned is 1 by something. If they come in front of me, I will tell them, what nonsense is this? Rankine's material constant. How dare you tell for end conditions? Have common sense. No. Then I will take actual length. Don't take actual length. Slenderness ratio you are writing. Their effective length. Why you are unnecessarily confusing students? See, I will be very harsh on them. Equal to formula is, remember, I told you it is what? It is sigma CR by pi square E, or equal to sigma CR is 325 divided by pi square divided by 205 10 to the power 3 equal to, it is a you usually do one thing, decimal will come, but actually it comes decimal. How much, tell me? Where is the answer? 325 divided by pi square divided by 205 10 to the power 3 comes to 0.0001663. Correct answer? 0.0001603. Correct answer? Fast. Correct or not? Answer. Okay. But usually people write that is alpha equal to, very popular way throughout the world is not to write point not something. Usually they write in reciprocal format. They write 1 by 6225.44. This is the popular version of alpha. Or when in examination sometime for students they give alpha. They give alpha always like this. Okay, over. Now with this data I will remove all this one now. Ella removed. Now you require lambda. Lambda is already calculated for when you solve by user. If some student will tell, sir, if user is not asked, find lambda now. Why you are waiting? If not done earlier, find it now. Okay. Then with that data, I will remove all this one. So Rankine's failure, red color. Why? Failure load. See, it is a red color because failure load. Okay. Later I will write. Rankine's failure load equal to 325 into area 12016 divided by 1 plus alpha 1 by 6225.44 into lambda square. Where is lambda? Oh, I removed the lambda only. Abba. Lambda. I rubbed out lambda. Tell me what lambda I wrote earlier. Oh, ee rogagalu. 1 nimisha. Lambda. I rubbed it. Tell what is lambda? Lambda 134.045. Okay. Divided by into 134.045 square. Or if you want to understand correctly, you do some other way. Therefore, PF equal to, see, 325, tell me, 325 into 12016. Tell that number. I will tell you why. You tell that number. I will tell you reason. Don't give full answer. Tell me 325 into 12016 in 10 to the power 3. 325 into... No. For some reason, to understand the concept, you tell those who are reading examination, do single calculation. But those who want to understand the concept, tell that number. Eto. Why this much difficulty? See, 320, you are not giving answer to me. You are making my life miserable. It is 3905.2, correct? 3905.2. 3905.2 10 to the power 3. This is the number here. Multiplied by, now tell me reciprocal of this number. Now tell me reciprocal. Why? To understand concept. Those who write examination calculated, throw the question outside. 1 plus 1 by 6225.44 into 134.045 square Whatever you get, take reciprocal and tell the number 0.2579. Correct? Is it 0.2579? Is this denominator number is 0.2579? Yes or no? Tell me yes or no. 0.2579. Tell me correct or not. No, I want confirmation. If I make a mistake, my logic is gone. 0.2579. If it's correct, I can go further. Otherwise, I have to check once again. Is the denominator value reciprocal format is 0.2579? 1 by the denominator. You are not answering anything. See, this is, yes, correct. Okay. Or those who want, tell the answer now. Those who want, write. Others, those who want examination, calculate and write and go to next question. Don't waste time. Those who want to know concept, you write. 3905.2 kilonewton is what? 3905.2 kilonewton is what? Tell me. Is what? 3905.2 kilonewton is what? It is sigma CR into A. It is what? It is the crushing load. If the column is really short, then this will come how much? If the column is very short, this number will come. That you should write. Those who are serious, write it. That number would have come how much? If the column is very short, that number would have come 1. Means failure load will be crushing load only. But that number came, this is what I told comment in the end of the class. But failure load came into 0.2579 means this column is not short, considerably long. Yes or no? See, 8 meter length, it is considerably long. Yes or no? It is considerably long. So Rankine told 20.2579 is 0.26. Okay, you tell, imagine 0.258. You imagine 0.258 just to understand. You imagine it as what? Just to understand discussion. Imagine 0.258. So Rankine told this is a long column. You cannot, this will not fail by crushing. Buckling also predominant. Therefore, whatever crushing load is there, you reduce the strength by what percentage? Tell me. Reduce the strength by, you take this as 0.258. Reduce the strength by what percentage? Tell me. What percentage? Rankine told you. You better reduce the strength by what percentage? Not 25. No. Reduce the strength by what percentage? Is not 75.8. 0.258 is remaining value. Ayo, how it came? I explained so much earlier. Reduce the strength by what percent? Not 25.8. Reduce the strength by not 25.8. Ayo, I told earlier. This is the reduction factor. Rankine told you should almost reduce the strength by 75% or 74.2%. Yes or no? Almost 75%. How 25? Tell me. So, if it comes to 0.25, tell me. If it comes to 0.25, strength reduces by what percent? Not 25%. Tell me answer. 74.2%. Only around 25% strength still remains. After from crushing to buckling, it has gone such a long that what strength the column will have if it is short. Now the column has only around 25% strength. 75% strength is lost. Clear now? Around nearly 75% strength is lost because of long column effect. Clear or not? Tell fast. I want clear or not. You told 25.8%. That's why. See, this should all naturally should come to mind. This should come to mind naturally, not by calculation. Clear? You tell clear, I will close the question. Time over. You tell clear, I will close the question. One clear required. Clear. Okay. No, is the concept clear now? Now the answer is how much? 3905.2 into 0.2579 is 1007.15. 1007.15 Newton, or 10. It's a red color. Why? Danger load it is. It is a failure load. The failure load is what? 1007.15 kilonewton. Therefore, according or as per Rankine's formula, the safe load you can apply is 1007.15 divided by factor of safety of 2.5 equal to, see, much lesser. Euler told you apply 541. Rankine told don't listen to Euler. He will not take direct compression. You listen to me. If you want your building to be safe, this column will fail at around 1000 kilonewton. You apply only how much? Tell me. You apply only how much? Don't listen to Euler, he told. Don't depend on Euler. You always depend on me. Rankine will tell you, I am dependable every time. Do not listen to Euler. 401.94 kilonewton. 94 ನನಗೆ ಗೊತ್ತಿಲ್ಲ. 95 ಆಯ್ತು ಬಿಡಿ. ಅಯ್ಯೋ ಒಂದು ಪೈಸಾ ಜೋಬಿಂದ ಹಾಕೋತೀನಿ. 95 kilonewton. Is the numerical example which took more than 1 hour. I have seen this question solved online in 2 minutes. Why? See, buckling load PB, pi square A by L effect square, pi square known, E known, I. They find I. They will tell something. They will tell L effective. What? L by root 2. Substitute. Euler's load came. Rankines. PF equal to sigma CR into A by 1 plus alpha lambda square. Sigma CR given, no. Area you know how to calculate. 1 is known. Alpha they will give in the question. Lambda, L effective by R. Substitute. You get the answer. Okay. Shall we go to the next question? Yes, sir will come. Okay. Next question. Nearly 1 minute, 2 minute objective question point of view or explanation more than 1 hour. Is the concept of Euler-Rankine application fully clear? Means tomorrow I will go for some logical questions and close the chapter. Because now anybody is a student on this much understanding, he can solve any question now. See, if the class is for 3rd semester strength of materials, my way of teaching is completely different. It is not that way. At least some 10-15 problems will be there. But these questions will make them easy to understand. If anybody is a student, they can understand everything and solve exam questions. Full clear? Shall I close? Already 9 o'clock. Full clear? Can I close? You are not commenting. Shall I close? Tomorrow I will close the column chapter. Why? I think I told almost every concept required for understanding. Okay, thank you.